This is an AC sinusoidal wave. Pretty cool, huh? Now, alternating current, or AC, powers your home, your phone, and many other devices that we use on a day-to-day basis. Now, the most common waveform of alternating current is the basic sinusoidal wave, although others do exist, such as the triangular, the square, and the sawtooth waveform. For simplicity's sake, we're just going to stick with the basic sinusoidal wave. Now, this is the mathematical equation for a sine wave with respect to AC. The voltage at any given time is equal to the DC offset plus the amplitude times by the sine of 2 times pi times the frequency times by time plus the phase. Now, the DC offset moves the wave up and down the vertical scale and influences the voltage at any given time. The amplitude is equal to half the total height of the waveform and is given in volts. The frequency is denoted by how many full cycles of the waveform occur per second. And the phase denotes the starting point of the wave along the horizontal axis. Another important aspect of the sine wave is that the frequency and the period are inverse of each other, meaning that if you're given the frequency, you can easily find the period of the wave, or vice versa. Finally, the period is how long it takes for a full cycle to complete. Now let's see an example. So, the voltage at any given time is equal to 5 volts times by the sine of 2 times pi times by 50 hertz. This means that the wave has an amplitude of 5 volts and a frequency of 50. You can also tell through calculations that the period of the wave is going to equal 20 milliseconds. Now let's try another example. So, the voltage at any given time is equal to 2 plus 5 times by the sine of 2 times pi times by 5 times by t plus 90. Now this is a little bit more complicated, so let's break it down. The wave is going to move up a positive 2 volts on the vertical scale due to the 2 being present in the DC offset. The amplitude is going to be 5 volts, meaning that the peak positive voltage is going to be 7 and the peak negative voltage to be negative 3. This means that the wave has a peak-to-peak voltage of 10 volts. The frequency is going to be 5 Hz, and the phase is 90, meaning that the wave is going to begin a full quarter of a cycle before the y-axis. Again, through inverse calculation, you can also tell that the period is going to be 0.2 seconds. Now, I'd like to thank you for joining me today and learning all about AC sine waves. Thanks very much. Have a nice day.